We can have a look at the structure of the atom, and as a first example we'll have a look at, say, sodium. Now if you have a look at sodium on the periodic table, you'll see it's got two numbers associated with it. Whoops. Two numbers associated with it, 23 and 11. The 11 indicates the number of protons, and the 23 equals the number of neutrons and protons. Let me write that down for you. So there you go. Next thing to say is, in an atom, if it's a neutral atom, the number of P always equals the number of electrons if it's neutral. So what we can say about sodium is it has, over here we know it's got 11 protons. The number of protons is also equal to the number of electrons, and then the 23 here equals the number of protons and the number of neutrons. We know sodium has 11 protons, so 23 take away that 11 gives you the number of neutrons here. Hopefully that makes sense. If it doesn't, just have a rewind of the video and you'll work your way through it again. The next thing to remember is that from a chemistry perspective, we're only interested in, by and large, the electrons, because the electrons are on the outside of the atom. The protons and the neutrons are in the nucleus. The bit on the outside is the bit that reacts with other atoms. It's the bit on the outside, it's the bit that touches. So we're just interested in these 11 electrons here. How are they arranged? A reminder, we've got a sodium atom here, and we've got the first two electrons here, and I can represent those by crosses. You can only fit on that first shell 2 electrons, so any more electrons, and remember we have 11 electrons, we've got 2 here, we need to add some more on the next shell. That shell can fit 8, which, if you count up, gives us a sort of 2, 4, 6, 8, and then here 10, which means if we've got 11 electrons in total, we've got 1 more electron. That has to go in the next shell. And so what we've been able to do is to draw an atomic diagram for sodium. There's a really nifty way of checking whether you've got that right. If you look on the periodic table, you should be able to see that sodium is in the first group on the left hand side. This bit here is 1 electron. That 1 electron, the number of electrons in this outer shell, tells you which group it's in. Sodium has got 1 electron in its outer shell, so it's in group 1. It's the furthest on the left hand side. If it was the next group along, we'd have 2 electrons in the outer shell. So that's one way of identifying where sodium would be, and also one way of checking to see if you've got your atomic diagram correct. The next way is to look at how many shells we've used. There's 1, there's 2, there's 3, so we've got 3 shells being used. You should find on the periodic table that sodium is in the 3rd row down, not the column, the row down. So there we've worked out the structure of the atom, structure of a sodium atom. I'm going to do exactly the same now for a fluorine atom. So fluorine has got numbers 9 and 19. That means that P, E and N, remember that P equals the bottom number, which equals 9. E equals the same number if the atom is neutral, and N is the difference between those two numbers, so that's going to be 10. Again, a reminder that when we're looking at atoms and chemistry of atoms, we're only interested in the electrons because they're on the outside of the atom. That's the bit that touches something else. The nucleus, which contains the proton and the neutron, is hidden inside. It doesn't react with anything, it's the electrons that react. So let's draw the structure of a fluorine atom. Here's fluorine. First shell, remember, can take a maximum of 2. If you look here, we've got 9 electrons left. So we've got more than 2, so we need to go to the next shell. Here we go to the next shell. 1, 2, 3, 4, 5, 6, 7. There's 9 electrons in total, count them, which is equal to our 9 here. So that should be the correct diagram, atomic diagram for fluorine. if you check on the periodic table, you should be able to see that fluorine is in which group? 1, 2, 3, 4, 5, 6, 7. It should be in group 7. It is. And if you look at how many shells are used, it only uses 2 shells. So it must be in the second period, the second row. So second period, 6th group, and that's correct for sodium. So that's really how you work out the atomic structures of atoms. Hope that helps. I just realised I made a mistake there. I said that fluorine was in group 6. It's not. It's in group 7, and we know it's in group 7 because it's got 7 electrons in its outer shell.